Okay, we're going to go ahead and get started. What I am trying today is I'm going to have the YouTube Live open, although there's a slight delay, so it might be kind of weird. But watching the live should be able to, yeah, there's a live chat, so I should be able to see any messages. So if they have questions, they can pass those to me. So I'll try to keep an eye out for that as we're doing things. And let's see. Check one more thing. Okay, but I'll turn the sound off, otherwise I'll be talking to myself a few minutes late. All right. Sure.
Where do you go to view the live stream? Is it just like on your Canvas website? Because I never actually.
It will be, yeah. So after it's done, I post it into Canvas.
Okay.
I post the links there. You'll be able to, if you have questions, you'll be asked through the live chat. We'll see how that works.
Okay.
We'll get all the details worked out.
Yeah. Well,
okay.
I keep remembering it. You have it. I never actually even thought about it. So.
Yeah, and
I actually want to use it. Good.
And usually what I do is once I record the link, I put it into Canvas, and then I send out an announcement. So you should be getting emails every time, which reminds you to do the attendance and should give you a link to it. Okay, good. That's what's supposed to happen. Okay. Too many different videos going on. So we're in lesson 2, so that's where I'm going to go right now. And we're going to work through the second half of the workbook, looking at some of the examples and the practice problems. Actually, we could just go to the practice problems. Because the workbook is, all of those problems are worked in the mini lessons. So on Monday, we went through most of these types of problems. As we scroll through it, does anyone see any types of questions that they would like to have as either a review or take a look at? Or if you had questions from the online homework. Otherwise, this is where we're scheduled to start today.
What would the exponent, when you have a fraction as an exponent,
then it just depends. It's the same rules that we use. So
before going through the next.
Yeah, so there won't be too many of those. Those just kind of make it. But if you're multiplying two things and it has a fractional exponent, you just need to add them.
Oh, okay.
And then again, adding fractions, you have to go back to those rules. You have to get a common denominator. So we did do one of those in class. The practice problems, let's see. I'm not sure we even have one in the practice problems. There are a couple here. So we worked these. We worked K, or one very close to that, on Monday. So that's in the video. And then the L question, those are the exponents are fractional, but it's an exponent to an exponent, so we would just multiply. So maybe we'll take a look at that just to. So on this one, change colors. simply going to be x, and then we'll multiply the two exponents, so 4/5 times 1/3. And with fractions, when we multiply straight across. So that will give us 4 times 1 is 4. 5 times 3 is 15. And that's the exponent, so our final answer is x raised to the 4/15. Does that make sense?
Well, it's confusing because, you know, I didn't, it doesn't look like we're supposed to multiply it, right? I guess. If the first thing I would think is like, well, no, it actually makes sense.
Okay, good.
Yeah, it does. For some reason I think I'm doing it, but I'm likely to be wrong.
Yeah.
Yeah.
What I typically would do with fractional things is I would replace them with whole numbers. So this is like x squared to the third. What do we do here? We're just going to multiply 2 times 3, so it's easier to see. And so we do the same thing, but now we've got fractions. So we're just multiplying 4/5 times 1/3. And they get to be a little challenging, but again, those of you going on into calculus, this is good practice because those are sometimes the kind of ones that you get hit on in calculus. And you thought you were understanding everything, and then you hit one of these, and then you think you don't understand it, but you do. It's just the complexity of working with a fraction that gets you. Okay, so we don't have to do a lot of these, 1 or 2 just sprinkled in to remind us that we understand the concept. On L, we're just multiplying fractions. It's just it's a little more difficult. On K, we're actually adding the fractions, adding the exponents. It's just with fractions, it's a little more complicated than just adding 2 whole numbers or integers. So let me take a picture of this. There we go. Just go to page 1. And then I'll let's make a new page. There we go. And let's go down to the part that we're working on today, which is sort of in many ways very similar to what we were working with, but it's got a few Okay, so this we're going to talk about combining functions. So we worked with exponents. We learned about adding like terms, adding and subtracting like terms. We did that. We learned about when we multiply things with exponents, dividing things with exponents, exponents to exponents. All those rules will now apply here. So the first thing is understanding what this notation is, though. So we are going to be combining functions. And what are the 4 operations we have for combining things? Adding, subtracting, multiplication, and division. That's pretty much it. And that's all we're going to talk about today is adding, subtracting, multiplying, dividing. But instead of just taking numbers and adding them, we're actually adding functions. Okay? We're actually multiplying functions, which, as you're going to see, is in the first steps really ends up breaking down to just either adding, subtracting, multiplying numbers, but we have a step to go first. So in these ones, they give us the definitions of the functions. So here's the f function, negative 3x plus 2. Colors here, green, and g of x is this function over here. So in each of these problems, we're going to start with those functions. And what is it telling us to do here, down below? What does it mean to find f of 4?
We're going to replace x with the 4.
Very good. So we could just bring down the equation, the function, -3, and where the x is, just put a parentheses, plus 2, so that's the function. And then what goes inside the parentheses? The 4. Okay. So that's kind of, and you could work this separately, get its answer, and then add it, but I'll just kind of do it this way, and I'll put it in a bracket, say that's the first thing we're going to do. And then what's the operation we're going to perform with that? Addition. So we're going to add to that g of 4. And again, how do we do g of 4? Good. So we come and rewrite the function down here. We replace the x with the parentheses. The square goes on the parentheses. Plus 4. Parentheses. Minus 7. And then we fill each of these parentheses what's over here in the parentheses for the g function. So now what do we have? Big mess of arithmetic to do in order of operations type things. And so I'll put a bracket around here, so we'll sort of work the blue bracket, get a number, work the green bracket, get a number, and then just add them together. Okay, so -3 times 4, -12. Plus 2, and again, you might have done that in your head and just written down a -10, hopefully, but sometimes if you maybe wrote down -14, you might want to check your arithmetic of sign numbers, but that can happen. And sometimes I push myself to go too fast and I start making some arithmetic errors. Okay, so, but do we agree it should be -10? Okay, good. Over here, 4 squared. I guess I should switch back to green. So we've got 16. 4 times 4 is also 16. And then we're going to subtract 7. And again, you might have done this all in one fell swoop. You put it in all your calculator, got a single number, that's fine. Looks 16 is 32. 32 minus 7. I'll write it down just to be safe. That should be 25. Okay, so 25. So we have a -10 plus a 25, giving us as a final answer 15. So that's what we do with each of them. And you'll see that really subtraction is not too much different than addition, except instead of adding, we end up subtracting. And with these, if you'll just work it all the way down, and then at the end you'll have 2 numbers. In this case, in the B option, you'll subtract them. In the C option, you'll multiply them. Okay, so it's really just getting down to arithmetic. First step is to plug in the values, set up the functions, and put these parentheses. Look like a piece of cake or slice of pie. I don't know, why do we always use food analogies, right? Some pieces of cake, are huge, they're hard to eat, right? They're fun, but they're hard. Okay. So any questions? You want to see any of these worked out? So we've got a, oops, I better take a picture while we're here before I start moving, right? Let's go there. We'll save this as page 2. And also this last time I posted the screenshots. Did anyone notice those? Or if you haven't taken a look, let me know if those are helpful or not.
Where are they at?
They're in Canvas under modules, and so what I'll do with each of the lessons, there's a lesson 2 separate module. And if you go into modules, you should go down to lesson 2, and then there'll be the same place I put the videos. It's kind of a content page. You'll see the videos first, and then below them you'll just see the screenshots, which will act as notes. And again, you could print those out. You could just take a review of them. You could compare your notes just to make sure you put the same thing down there, rather than, I mean, it'll be the same thing that's in the video, but it's more static. So we'll have both the static version of the class of screenshots as well as the videos. And that way you can also go back as you review for a test. Maybe you need to look at something. Okay, so are we okay so far? Okay, good. So we'll start off with a new one, and let's see if there's anything different. There is the division. So it looks like a fraction. Is that anything all that different? Or you want to take a look at it? Not sure? If we're not sure, maybe we'll take a look. And then we'll get into basically the ones in 17 are plugging in set of numbers, variable x. So we'll see how that one's done. That one you have to be a little more careful. Let's go ahead and do this one, I guess. Let's, well, maybe. So we're going to divide. So g of x, remember, you'll look up further in the page. Let me see if I can do it without looking. I think it's something squared plus 4x, which is just going to be 4 parentheses, minus 7. And again, what we put in each of those parentheses is going to be 0. So it's actually, this is an easier one. When we plug in 0 for x, where are we on the graph? Where's that?
Like the starting point.
Good, the starting point. Which axis are we on, though? Are we on the x-axis or the y-axis?
Oh, x. It's still the value of x, but.
The value of x is 0.
So it crosses the plane.
We could be at the origin if the y is also 0. And in this one, we're going to see, we're going to end up with a negative 7. So x is 0, y is negative 7. So we're no longer at the origin, but where are we?
We're just at negative 7 on the y-axis.
Excellent. We're at the y-intercept. Okay, so we'll see this, we'll be asked this question about y-intercepts. And that's perfectly good, the way to describe it. It's the starting point, but when x is 0, we're on the y-axis, somewhere on the y-axis. We start at the origin, but y is allowed to go up and down, but notice x is not allowed to move. It is 0. So it's like under house arrest or something. It can't move it can't move away from the origin. It's still going to be the y-intercept. And we'll see later on when y becomes 0, the same thing will happen. Y is sort of under house arrest. It remains somewhere on the x-axis. Okay. Let's see, I forgot, f is something like 2x plus something?
Negative 3.
Oh, negative 3x. Or no, 2x plus negative 3, or 2x minus 3?
Negative 3x plus 2.
Thank you. Okay, so I'll keep it in blue just to match what we were doing before. Negative 2x, or did you say 3x?
3x.
My memory is so short. Okay. Negative 3x. I'm very visual. Plus 2. Okay, I did remember that part. Okay. And again, in the parentheses, we plug in whatever's in the parentheses over here, so we put in a 0. The top 0 squared is 0. 0 times 4 is 0. So those are nice. Those all just become 0, and then we got a negative 7. So just negative 7 on top, in the bottom. Negative 3 times 0 is 0, plus 2. All that remains is a 2 in the bottom, and that's our answer. It can't reduce. We're done. So you could write it as negative 7 over 2, or if you want, you could write a negative out front with the 7 over 2. These both mean the same thing. Okay, so the first part, that's all you're going to be doing, and you'll do this a few times. Let's see, I should have gone up a little bit higher, but take one more shot, and this will be page 3. Okay, get us another page, and then we'll come up and we'll take a look at each of these, because these are a little bit different for each one. Okay. Yes, go ahead. So we've got a different definition of f of x now, and a different definition of g of x. Again, the same thing, we're either going to add, subtract, multiply, or divide. But this time, notice we're not plugging a number into the function, so we don't end up with just numbers, we end up with expressions. Okay. So the first thing we want to do is rewrite the function f of x, plugging in x for x. So we're not going to use the parentheses this time, we'll just write it as 2x minus 4. Now you'll see we don't actually have to do this, but I'm going to do it. I'll put a parentheses around it to emphasize that that is all f of x. Okay, so it's sort of separate. But there's nothing in front, there's no exponent on top, so these parentheses really are not necessary. And as you pick up speed and understand this, you'll probably just leave them off because it's cleaner. But I'm going to show you with subtraction, they play an important role there. Okay. And then what's happening between the two? Well, we're going to add. So I'm going to put the addition sign, and then we're going to add all of g of x. So I'm going to put a big parentheses, and in there, what do I put? G of x. G of x is just x squared minus 9. Okay. So this is how we're combining functions. And we can see that there's nothing in front of the parentheses on either of the parentheses. There's no exponent on either one, so it's safe to just kind of remove them. There's a plus sign in front. You could think that this plus sign is going to distribute, but really it's a plus 1. So when we multiply by 1, what happens? Well, nothing changes. So 1's a great, it's called the identity function because it doesn't ask anybody to change. Isn't that great? They love you for who you are. So, yeah. So we end up with 2x minus 4 plus x squared minus 9. And then what do we have to do? What do we call this part of the operation? Well, we did the, yeah, we distributed the plus sign. And
combine like terms?
Now we combine like terms. So we look for like terms. Well, we got a 2x and an x squared. Those aren't like terms, are they? So the negative 4 and the negative 9 are like terms. So we could just rewrite this with, and again, sometimes just to make it pretty, we put the x squared first. We put the 2x next, and since there's no negative in front of the 2x, there must be a positive 2x. And then negative 4 combined with negative 9 is going to give us what? Good, negative 13. So be careful with that. Sometimes people will want to actually subtract them because they see the subtract sign. But since they're both negative, they're both going in the same direction, they both become combined together, negative 13. And that's all there is to it. So kind of similar to what we were doing earlier, it just really ends up being combining like terms. We just write them together. We're going to add them with addition. There's really nothing to worry about. So far, so good. Let's do the same thing with B, and we'll see that it has one thing that causes more trouble than maybe it's worth, but it won't cause you trouble if you remember the parentheses. So again, this time they've got g of x first. Okay, so that's the other thing. Order is important, especially with subtraction. So I better go with green first. So we're going to put the g of x function, which is x squared minus 9. Then we're going to subtract the f of x function. So I'll switch to blue. And again, I'll put my parentheses. Now, I've got a lot of students who won't do this, and some do it correctly and some don't. If you do it correctly, and you'll see what that means, you're fine, but if you don't, please put the parentheses because it'll help you with this next step. 2x minus 4. So in this, what is the first thing we need to do? We've got these parentheses. What's that?
Combine the lights.
Well, before we combine the x, we really have to take the parentheses off, right? The front parentheses, is there anything to do? There's no number in front, there's no exponent. How about the second parentheses?
Multiply by -1.
Good, there is really this -1, and -1 is not so nice as +1. +1 accepts you for who you are. -1 wants you to be the opposite. Okay, so -1's kind of, yeah. Wants you to change. So it wants 2x not to be positive 2x, it wants it to be negative 2x. And most students, if you don't write the parentheses, that's what you end up with, so that part's correct. But what ends up happening is you forget that this -1 is going to change -4 into what? Positive 4. So that's what happens without the parentheses. And again, as you work through these, if you just realize that negative is going to change every sign there, and you write everything with change signs and you don't put the parentheses, that's okay. In fact, that's a very efficient way to do it. But if you're like me for years, I would just put a negative and then I wouldn't change the other signs. So you end up getting wrong answers. So this is what we need to do. The front one, nothing happens to it. So we have our x squared minus 9. And again, it really is just combine like terms. But notice this time, the answer ends up being a little different because we're subtracting. So still x squared has no partner for itself, so it stays x squared. 2x is now negative, so we write it as minus 2x. And now we've got a -9 but a positive 4. So when we combine those, what do we end up with? -5. Opposite sign, so we subtract. 9 minus 4 is 5. The 9 is bigger in magnitude, so it keeps the sign of the bigger magnitude, so it'll be negative. And that's that. So notice, in a sense, not much difference. You just, when you're subtracting, change the sign of every term in the second function, and you'll be safe. And then it's just combine like terms. Not a big deal. Again, sometimes it's mostly just the notation, which seems to be new, and getting used to that, the function notation. All right. So what do we do next with C? What's our operation? Multiplication. So again, we just write down both functions, and the f of x is first this time, so 2x minus 4. And again, we just group it in a parentheses. We may or may not need this. In this case, we're going to see we do need it. And then we write down the g of x function. Again, I like to use colors because it emphasizes a separate function here. G of x is x squared minus 9. And notice whoever did the workbook, they gave us a little bit more room, which indicates, yeah, it's going to take a little bit more work with these ones, right? And again, what are we doing with these two functions? We are multiplying them. So how do we do that? We FOIL, exactly. This is the FOIL one, where we multiply the first, multiply the last terms, then we'll multiply the inner terms, and then we multiply, first, outer, inner, and then last. That's why I didn't like FOIL. I always got the letters mixed up, but I knew what to do, right? So 2x will multiply by both terms. negative 4 will multiply by both terms. So 2x times x squared. That's going to give us what? 2x to the third, right? We're really adding exponents, so if it helps, you might want to put the little 1 on that exponent. 2x is really 2x to the 1. And we're adding exponents. So that's why I wanted to give you a day to work through the first part instead of jumping into this the first day. We probably had some time. We could have looked at a few of these, but I find if you do it over time, you're better off. And then we take 2x times 9. So what, that should give us like 2 times 9 is 18. Positive times a negative is negative. And then the x just tags along for the right. Okay, so that takes care of the first term. We come along and take the second term. So it's going to be negative 4 times x squared. And the sign is going to be negative times a positive is going to be, the sign will be negative 4x squared. Is that okay? Good. Let me check our live chat over here. Let's see. Hide the chat. Okay, so it looks like we're okay. Oh, one person's watching. That's good. So hi. I don't know who you are, but thanks for watching. If you have any questions, I'm watching the chat, so feel free to buzz in with any questions. Okay. Where are we? Oh, the problem. Then we got to take the negative 4 times the negative 9, right? Okay, so that's negative times a negative gives us a positive. 4 times 9 is 36. Now, are we done?
Yeah.
Sort of. There's no combining of like terms, but we might, those of you who are very like a tidy house, you're going to want to maybe get in an order of the largest exponents. So 2x to the third, that should go first, and it is, so we'll do that. And then you might want to move the x squared up. So it's just really just reorganizing. It's not absolutely required, but it just may be how the answer appears in the back of the book, or if they, it's really going to give us the same function and the same function values. So, but just cleans it up a little bit and sometimes makes it a little bit easier to recognize. So we are now 3/4 of the way through the lesson. Because this is the hardest part of it. We'll look. We'll see if there's anything any harder, but I think not. First ones we plug in numbers, so we're used to doing that, and then we're just adding numbers, subtracting numbers, multiplying numbers, dividing numbers. This one we're just doing it with functions, and watch how simple D is going to be. You thought division was hard, right? Because it usually is, but in this case, division is going to be the easy one. I love division with these ones. Okay, so when we get to the division, the G's on top, the F is on the bottom, and that's important. We can't mix that up. So we're going to start with the top. And what goes in the top? Excellent. And then what goes in the bottom?
2x minus 4.
2x minus 4. And what do we do next? We circle it because we're done. So wasn't that nice? Really? If you could, sometimes the top one could be factored. Actually, we'll learn later on that x squared minus 9 can be factored into x plus 3, x minus 3. But that doesn't help. It doesn't really change anything. So still, we couldn't do anything. There is something called synthetic division, which I'm not sure why we did it, because we stopped teaching it, because it's like it was really not really that important, I guess. There's some places in calculus where it does, you do something called partial fractions, but that's it's a long ways away, and it doesn't get, it's kind of a special case thing. So you may never need to do it, especially if you're going into business calculus. You won't use it there. They've got other options. So it's kind of like we said, if we need to divide it, we're going to do this. Now we will study these kind of functions. This is called a rational function. A rational function is just a fraction. So it's got a variable in the bottom. They behave some nicely, but some usually not so nicely. We will study these. These will be our last unit of study, is radicals and rationals. We'll study them all together. So we'll take a look at them, but this is all we had to do. Put the top in the top, the bottom in the bottom, and circle it. So now don't you, like, at least with these problems, aren't you looking forward to the division problems? They're pretty easy. Yeah, this is all there is to it. I love it once you get down to it. You look at it and you think, oh, division, a fraction, it's going to be hard. But these are actually end up being the easiest, because that's all we do with them. All right. So I'm going to take a picture of this. So it'll save in the notes. I think we're to page 4. Good. And then I'm going to just get another page. Now, if you had questions on any of the previous ones, you'll notice down here it's saying page 5 of 5. The pages are actually saved. I can go back. I can page backwards as well by just clicking on this one. So I can go back a page or forward a page. I may have to line up my notes that we're working with because they're kind of two separate things. Okay, and then what you see is just a lot of problems to practice with. Two functions, add them, subtract them, multiply them. Two functions, add them, subtract, and see they kind of figured out that we were going to catch on that addition or division is real easy, so they stopped giving them to us. Oh, man, why do they do that? Only give us the hard ones. Addition, subtraction, multiplication. Two functions, multiplication, and now they mix it up. So we're going to multiply. Notice they're mixing them up a little bit in C. You're getting some with numbers, which were like the first ones we did, and you'll actually end up with a number. The other ones are functions. Just foiling them out. And again, so multiplication does get to be a little bit the heavier one, the heavier workload. The addition subtraction is really just like terms. And okay, they give us a few. Oh, cool. See, these are all going to be easy ones, aren't they? Now, what's that?
I said that one is horrible.
It does look horrible, and these ones actually, now that I told you that the division was the easiest and you didn't have to do anything at all, they give us a couple where we actually can reduce them, so I'm going to show you these. Do you want to take a look at A, or do you want to take a look at B? Or do you want to take a look at both? So we'll do A. If we need B, it's still there, but it's really going to be the same as what happens with A. Okay. So let's go ahead and do colors again. So we'll just keep the F function at B, and then we'll make the G function green. So, but while I'm here, I'm just going to write this as 3/2 x to the 4th, minus 3x to the 7th. And then the G function, we're just going to write that down. 6x to the 4th. And in some ways we could say we're done because we do have a function that we can graph, but this one actually will simplify. Now I can't remember if it was here or in my Math 90 class, because we do this in Math 9, or at least we used to. Did we do some where we distributed division? Have we done any of that? Okay, I think that was in my Math 90, so there's this disconnect. So you probably saw it, but it would be like a whole semester ago. You would have saw it at the beginning of Math 90 if you had Math 90 last time. So, but we did talk about distributing because we talked about FOIL, right? So when we multiply, we distribute. What is the relationship between multiplication and division? they're opposite operations, but they kind of are sort of for the same purpose, right? Just like addition, subtraction. So the thing is you just have to remember with division, division will also distribute just like multiplication does, except it's not multiplying, it's dividing. So let me show you how this works. So we're going to take the 6x. Now some people would do, okay, this x to the 4th cancels with the first one, and the 6 cancels maybe with the 32, I think, I don't know. But they would cancel only with one of the terms. But when we found out with distributing, can you just multiply by one of the terms when you distribute? No, you need to multiply by both, right? See, if I have 2x plus 5. Could I just say, well, let's just take the 3 times the 2x and be done? I mean, I could, but I get it wrong, right? Because we need to take this 3 times the 2x, but we also need to take the 3 times the 5. Okay? We have to distribute. The same thing happens with fractions. You have to distribute the denominator to both of the terms. So what it really does is it gives us 2 new fractions. 32x to the 4th and 6x to the 4th. Now this works well if the denominator is a monomial, a single term. We didn't do it before because we had a binomial, we had 2 terms, and it's just a mess, so we say let's not bother with it. It's not going to make anything any nicer. Again, there is methods to sort of, quote, simplify it, but they aren't fun and they aren't nice and they don't give us anything more usable, so we don't do it. This may give us something more usable. So then the next thing we do is for the next fraction, we'll take this sign in the middle, the subtraction sign, and we'll put it down here. And then we'll put the 3x to the 7th in the top, and we'll put the 6x to the 4th in the bottom. So we have distributed division. It looks weird because we were never taught to take a fraction and break it into 2 fractions. We were taught to go the other way, to get a common denominator and add fractions together. That's been our career of mathematics since 1st grade or whatever, kindergarten maybe, some of us. But we've never been taught to do this, and so it seems kind of strange. But if we do it this way, what can we do now as far as simplifying or reducing this fraction? What's x to the 4th divided by x to the 4th? 1. They cancel. Does 6 go into 32? Not completely, but 2 goes into both of those, right?
Yeah.
So 2 goes into 6 3 times, and 2 goes into 32, is that 16 times?
Yes.
Okay. So bust out a calculator if you need it. I got help here, because if I make a mistake, you guys are going to catch me, right? So it's going to be just over here, 16 thirds. That looks nice and simple, right? The variable canceled out. The second term, I'll put the minus sign here. Is there any canceling type stuff we can do here? There's an x to the 4th, x to the 7th. What's going to happen with those 2 guys? This takes us back to Monday. We subtract them. Very good. So the top minus the bottom. So 7 minus 4, we're going to x to the 3 left in the top. If there were more in the bottom, they'd be left in the bottom. Okay, so it's just kind of easy. Just subtract them, and then it's just, think about moving. If you got more in the basement, just leave them in the basement. If they're more in the upstairs, leave them upstairs. Don't do more work than you need to. But this one, yeah, these 4 sort of cancel out with 4 up here. So I'll cancel out the 7, and 3 are going to be remaining up there. And again, 3 and 6 also can cancel out. 3 goes into 6 2 times. So what's remaining? Well, what remains in the top is just x to the 3rd. And all that really remains in the bottom now is a 2. Now, doesn't that kind of look simplified? It does. So that was worth doing, maybe. I mean, we could have left it the other way, but this is maybe a little bit easier to deal with now. Okay. Whereas if we have binomials, it's not fun, and it rarely gives us something that is more usable or more simplified. So we pass on it for now. You'll learn some techniques if you take the sort of the physics-based calculus, because sometimes you'll deal with those. And we'll learn some other techniques along the way. 150, you'll see a few more, but otherwise, especially if you're going into business calculus, you won't have to worry much with that. Does that make sense? And then what's going to happen with b? Since this is in the denominator, again, it's going to distribute really the same thing, but it distributes to 3 of the things. And without going through all the work, I'm just going to set it up. It really will become 48 x to the 9th minus 16 x to the 3rd plus 4. And I skipped a step. I didn't set it up, but from above, oops. You see the delay on this stuff is there. Okay. And then what goes in the bottom? The g of x goes into each of these because it would have distributed. So I skipped the step of setting it up as one fraction and then breaking it into 3. Any of you guys that way? If you can maybe cut a step, you'll cut it so you don't have to write down a lot of stuff. I know, I was always that way. Sometimes it gets me in trouble because you miss a step and then you did something wrong in your head. But does this make sense? Remember, I skipped a step. I would have set it up and then distributed, but this is where we would have worked with, right? Questions on that?
How do you distribute the 8? By putting it in the denominator?
Yes.
So you don't multiply? Oh.
No,
yeah.
no, yeah, we dividing, yeah, the negative 8 x to the 3rd, that whole term is in the denominator. And again, the step that I skipped was up here. I would have done negative 8 x to the 3rd, and then I would have had 48 x to the 9th minus 16 x to the 3rd plus 4, and then I would have distributed, and I would have ended up with 3 separate fractions. So I just wanted to show you that you could jump to it and say, well, let's just go ahead and distribute. That's what it's saying. Take each of the terms, divide it by g of x. And then you can reduce each of those as you go, and you'll get something maybe a little more simple. And then you're done. Okay. You want to see this one, or are you okay with this? Sure. Okay. We're almost. Okay. So again, variable parts can cancel. There's 9 in the top, 3 in the bottom. So these 3 cancel out with 3 up here. So 9 minus 3 is 6 are left. And then the number parts, 8 goes into 48, doesn't it? 6 times. So 8 cancels itself out. 8 divided by 8 is 1. 48 divided by 8 is 6, right? And notice the negative is going to have a negative on it. So after doing that, I'm going to have a negative. I'll have a 6 in the top. I'll have an x to the 6th in the top. What do I have in the bottom? Good. There's a 1 there. Now I don't have to write it but I'm just going to put it there. It's not that I have a 0. It's not that when everything's gone it's 0. It's 1. Very good. And then we do the next one. Now a negative in the bottom and a negative here. Doesn't that kind of cancel out and make a positive? 16 cancels with the 8. And 16 divided by 8 is 2. So part of this is just reducing fractions, and the other part is reducing the variable part. 3 in the top, 3 in the bottom, perfect match, right? Those just cancel each other out and become 1. So we're left with, it looks like just 2. And you could write it as 2 over 1, or you could just write it as 2. And you can see this, so we'll rewrite it maybe this way. But then at the very end, we got this last term, right? 4 goes into 8, so 4 cancels with itself. 8 divided by 4 is 2. There's no x's to cancel out. There's a plus here and a minus, so what's going to be the final sign on this term? Minus, because a negative times a positive is negative. So we're going to have minus. Now, the top all canceled out. So what's there? Very good. There's a 1 there. And in the bottom, there is 2x to the third. Okay. And again, you don't need, I guess you could come back and take away this 1 if you wanted to. Not have it as a fraction. Just rewrite it. Six x to the 6th. A little bit cleaner. And then this is a perfectly good answer. So it looks a little bit more cleaned up than the first step, and certainly than the 3 fractions. So it's, again, worth maybe doing. So you'll see a few of those. Well, 2 of those. Okay. And you might see some of those in the online homework as well. Okay. Oops. I better take a picture. Let's see. There we go. What's that? Take a picture. I think this is page 5. No, we've already got page 5. So this must be page. No, this is 5. Right. I just need to look there. Okay. And then we'll get a clean page before we move on. Now the last ones. Remember, functions are not just equations. Functions can be just table of values. But we'll take a look at a couple of these because sometimes, I'll just tell you they're so easy, but sometimes that's what makes them hard because you're not quite sure what to do. There's not that much to work with. So we'll take a look here at f of 2 and g of 2. So what are we doing with f of 2? We're going to add it to g of 2. How do I find what f of 2 is? Come here. When x is 2, I look up in the table. There it is. It's 15. So the first number is going to be 15. And then I do the same thing for g of 2, right? But I look on the other table. So I come when x is 2. I look it up, the answer is negative 5. So I'm going to add a negative 5. Okay, notice I keep the same symbols. We're adding, not subtracting. Although the end result is, what do we end up doing? It's really 15 minus 5. So that gives us what? Positive 10. Good. That's it. And we do the same thing with each of these. It's look up the values. So g of negative 1, so maybe this is where I'll change colors. So for b, we'll use green. G of negative 1, I come to the g function, look up negative 1, and then look up its output. So g of negative 1 means give me the output. There's 8. Subtract f of negative 1. So I come to the f function. There's the negative 1. I look up the answer. It's 0. So I have 8 minus 0, which is 8. Okay. The ones with multiply are the same. You'll get 2 numbers, multiply them. the divide, get two numbers, divide them. And you can either list it as a reduced fraction or as a decimal, however you want. It's, but same process, look it up, get the numbers, and then just do the operation. Not too bad? Okay, just needs a little practice. And again, oops. There we go, we'll take a picture here.
Are we going to do, I'm not really sure what it's called, but there's problems where they'll ask you to find what's next in the table. Or.
Oh, I see,
I
okay.
think what's probably realistic is that they'll give you a table and you'll have to fill in some links. But I have seen like questions ask me to like continue the table. And
They would only do that if they give you, at this point, if they give you the equation part of the function. So if they give you like 2x plus 4, and then you could plug it in and find it.
Can you go to the word problems and how to get the profit when you have like
Sure.
the revenue and the cash?
You got it. Because this all stuff is just look up and do, right? And I think you can, they probably have a few videos in there that do it. We can look it up on graphs. Maybe we'll come back to that if we need to. And then we've got a few word problems like these. Or 25. So let's.
As it kind of breaks it down, I'm kind of lost on the steps of how to get to the profit.
Okay.
You subtract is it the revenue subtracted from the cost or the cost subtracted from the revenue?
Right. What's going to be positive? Revenue. The revenue in. Costs are always going to be, we have to pay them out, so they're viewed as negative. So it's always going to be revenue minus the cost. That's our profit. And one other thing is oftentimes we think of revenue as profit, but revenue is the income we generate before we subtract the expenses. But a lot of businesses, we pay those expenses first before we get it, so then we think this is all my, I'm selling stuff, that's all my income because I've already paid my expenses. But in math, we look at it, no, your revenue, and then you subtract the expense. That's what your true profit is.
I guess like imagine if you were like resupplying constantly.
Yes, right, because then you have to go out and buy, you have to take some of that revenue to buy your next product before you can sell it. And that's really what happens.
Some things they always have to sustain food.
Yes. And at this point, what you're really mostly dealing with is are going to be linear type equations. So there'll usually be some kind of a fixed cost and then some kind of a variable cost. It costs so much per item. So like in this one, let's come here. So Leonard started a new business, making cartoon bedspreads. His monthly expenses are $13.22, so that's like for rent, it's a fixed cost. This is the fixed cost. And then we know this one's the variable cost. It says each bedspread costs $8.50 to produce, so it's materials and maybe labor. So what that does is it leads us to he pays $13.22 in costs, plus for each bedspread he makes, he's going to pay $8.50.
Is that $8.50 N?
It is. And the N is how many bedspreads he makes. Good. And this is the cost function. So I did it up here, but so C of N equals this. And then we can start, if he doesn't make any bedspreads, what's his cost? Well, $13.22. So it's like if you just get lazy and don't do anything, you're still got to pay your fixed costs. If he makes 100 bedspreads, then it's going to be 100, so that's 850, right? Oh wait, maybe I got that 850 right? Times 100. So you're just taking that function plugging in the various values, and you can build a table. So it's 850 plus 1320. 2 is going to be what, 2142?
2172.
2172, thank you. And again, that's where it's good to have a calculator. And you could put this in your y equals and then just look up in a table how to do that. And what I'll do is again, I do have a TI calculator emulator here, but it doesn't work very well on the second screen. But usually what I do is we'll do this, we'll be in linear equations. With linear equations, I think we get into regression. I'll show you that, and that's where I'll start bringing in how to use the calculator. And then from here on out, a lot of it is going to be how to use the calculator to come up with these values. Okay, and so again, you'd fill in these and so far. Okay, Leonard is selling each bread spread for $17.50. So this is where the revenue function oftentimes becomes easier. So how do we calculate our revenue? Well, each time we sell a bread spread, we get cash of $17.50. So that's $17.50 in. But this is 2 different time periods. We made them, now we take them to the carnival or wherever we're selling them at. We go ahead and sell them, and notice there's nothing subtracted off because this is just cash coming in. And then at the end, we'll calculate profit by taking what we made, subtracting what it cost us to make those things. Okay, so if we don't sell anything, we don't have any revenue. We sell 100, move the decimal over 2, we end up with $17.50. And if we look up in the table above, it actually costs us more than that to make them, so we better be able to sell 100 a month. 200 would be twice this, 300, 400, so you go ahead and fill those tables in. So far, so good? Okay. And then the final, what's the profit? Well, this is where the combination of functions, the profit function is just going to be the revenue function minus the cost function. And again, you could plug these in and actually get a final function, right? So there's 1750 and we're going to subtract everything up here. This is where I mean sometimes it's easier. The 1322 is going to be negative, and the 850, maybe up here, 850n is going to be negative.
So that's gonna be 1,322 minus 8.50.
Yes. Good. And again, you could have put a parentheses around here. The negative would have distributed. That's why that term that was a plus under the cost function is now a minus under the profit function. And you see you've got some like terms. You've got 1750 minus 850. That gives us $9. I think it is. So we can rewrite this the profit function more simply as simply 950.
That's $9 exact.
$9, thank you. I said $9 the first time, didn't I?
Yeah.
But when I went to write it, I just saw the 50. I thought I should write it again, but it happens. So you'll see. I still make all the same mistakes I made when I was a student. Hopefully it helps you. If it irritates you, let me know, and I'll. But what I find is it's usually helpful because as you catch my errors, then you aren't the one that's going to make them.
Oh, just ignore it.
Oh,
Okay, so we have a new function, and basically that $9 now tells us the net dollars we make for each spreadsheet, and then we just figure we have to cover our fixed costs But the variable cost is that each one's going to cost us $8.50. We're selling for $7.50, so we could think of it as making a profit of $9 on each one, but we don't really make the profit until we've also covered our fixed costs. But we do make sort of a variable cost profit each time we sell it. And then in the future, once we've made our sort of the break-even point, once we've had our fixed costs covered, then it's true. Every time we sell one, we're literally making $9 because we've covered our fixed costs, and then it's $9 of profit for each one. And that's where you get into business calculus. That's what's called the marginal. And that's what they look at, is because you need to plan to sell enough to cover your fixed costs. And then you look at the thing called the marginal, is how much do you make each time you sell one, and that's all you really focus on anymore. But in the beginning, you focus on it all. Does that make sense? I think that's 25. Looks like it's the last problem. Well, maybe not, but there's similar problems to it. And then again, once you've got the table filled in, there'll be some questions that they ask about it. Let's take a picture. This is page 7. Yeah, and so, formalize it down here. We've kind of got them all written. Where does it mean to break even? So when is our profit 0? That's what we broke even. One is to make an estimate, and then one's to actually find it. So it'll work you through those ones. And again, we'll work on these problems more as well when we get to the linear equations, and I'll show you ways to use your graphing calculator to solve them. But we do come back and solve each one of these. What this part is really working on is understanding sort of how, and these are kind of extremes, because lesson 3 is going to be strictly about linear equations, so we will be setting these up. Right now, it's you set up the cost, you set up the revenue, subtract them, and you get a new function. And so it's trying to motivate you that there's actually an application for this combination of functions. But we'll do lots of this in lesson 3. And then we get to a review section where it just basically has us, combining like terms, multiplying, and just doing some skill-based stuff. And that's really all we need to be able to do for this one. Okay. Look it up in a table. And then the only thing we didn't really do, let me take just a couple minutes to highlight what we do when we have graphs. That's right here. So how do we find f of 0 and g of 0 on a graph? We go to x, which is x is 0. Again, sort of we start at the origin. Now, which way do we go? We're looking for y, right? They gave us x is 0. We're looking for y. So we go either up or down until we hit the graph, and in this case, we had to go up. And what's our output? It's a y value of 4. We do the same thing with the g graph, g of 0. We come to where x is 0, where the input is 0. We go up or down until we hit the graph, and in this case, it's by going up that we hit the graph. And our output value is 5. We take those two numbers, add them together, because that's what it tells us to do, and we're done. Okay, so each one of these is just going to be a lookup. Sometimes 0 is the hardest one to look up because you're not sure. You come to 0, 0, but sometimes you go left and right when you're supposed to go up and down, and vice versa. Usually when you have the other numbers, this one f of 2, you just make sure you're on the right graph. You come to 2, and then again you're going up or down to find the y value. In this case we go up, the y value is 2, so f of 2 is actually equal to 2. And we look up g of 3, come to g of 3, go up or down, again it's going down, that hits the graph, and our graph value is -4. So we subtract. -4. And again, subtracting a negative is the same thing as adding, so 2 plus 4 is 6 will be our answer. But that's all that's, it's different because we're looking it up on a graph. We don't have a function, we don't have an equation to look at or plug it into, but it's also like another way of doing math. And each one of those will give you some practice. And those are really the range of types of problems you'll be dealing with in the online homework. Yes, sir.
Is problem 23 is exactly the same as 25?
Let's take
Or
a
is
look.
it different?
'23. Function E of n represents Ellen's budgeted monthly expense for the first half of the year. Table n equals 1 represents January, February, March, so forth. And then the second one is Ellen's monthly income for the first half. So we've got income and we've got expenses. At the end of each month, Ellen puts any extra money into a savings account. The function S of n represents the amount of money she puts in. It's similar, but they don't ask us to come up with equations. They just give us values. So to find out the amount in savings, all we're doing is we're taking the income minus the expenses. Okay, so it's sort of similar, but it's everything is just a number. So S of n is going to be I of n, the income, minus the expenses. Oops. And you could kind of probably do this without thinking about algebra. Because basically we're just going to take the first month and subtract the expenses, and the difference goes into the function. The second month we do the same thing. We take her expenses or her income, subtract the expenses, whatever's left over goes into the savings. So it's, yeah. See, first month, let's just figure that out. That's, she has 587. Thank you. So we're just sort of filling in like this and so forth, and then we can use the table to answer the questions after that. She estimates that a trip will cost her $2,000. Will she be able to save up enough money? Well, again, this is each month she's saving, so it's not, if you want to figure out how much she saves over time, then you have to add each month together, and then we'll see if she's able to get the 2,000. 587, that's a good start. If she could do that each month, she's okay. But you see, there's some months where she has some big expenses, right? And like the month 3, she actually has a negative, so she had to dip into her savings to actually pay all her bills. So it looks like what that looks, $40 negative. I did that right?
Mm-hmm.
So again, you just fill in the table, and then if you add it all together, you can see if she saved it or not. So it's really a table value process. Very good. So I think that's 9 pages. Oops. Save that one. And if there are no further questions, I think this is a good presentation, and it gives us about a half hour. If you had any further questions, we can work on those individually. Thank you. That's why I got you guys here. You always remind me to do something, because we got to do attendance, right? So let's do our word of the day. So we've got one more thing to do. And let's go with yellow, and let's make a nice, let's see. So who's got a good word of the day for us? Hunger. Okay. You didn't get lunch yet, did you?
No.
Okay. Okay. Hunger. check with our folks. Says say something. Word of the day is hunger. I sometimes forget, it looks like I got a little message. Maybe they were just testing me on the chat side. It says say something. So we'll see. So those on the live stream, I guess there's only one of you today, but if you do come on the live stream and you send me messages, we'll see how that works. So hopefully you'll be able to also ask questions from there.
I would do it. I just prefer coming in.
That's great, because it's good, but
I'll
it's
definitely chitty chat. So
yeah. But sometimes car breaks down or you're feeling sick or whatever. That's what the goal of this is that you're always able to do it. Or sometimes you saw something, but then you go home and you forgot it, so you could watch it again, and you can fast forward it to it, take all the boring stuff out of class, which I don't know how much that is, but you figure it out. Okay. All right, so we'll cut off the live stream and we'll just go into person-to-person mode.